Today's topic is principal disjunctive normal forms, and this is from mathematical logics. The problem of yours might be not being able to understand this topic despite trying so hard is going to get over. As I assure you that you will never ever fall out of ideas in solving this most important problem if you listen carefully till the end of this video. See here, in this video I'm going to explain first of all the definition, and next the working rule, and next the problems related to PDNF without using the truth tables. And in my next video I'm going to upload the problems related to PDNF using truth tables. Both are most important, and these questions are taken from the previous question papers. And see, please, I request all of you to lend your ears till the end of the video so that you can understand this concept very easily. See, in order to solve PDNF, so first of all, you have to learn the definition. What is PDNF? Before going into that, so we have to learn what is minterms. So I'm going to explain what is this minterm. The minterm consists of conjunctions. See here, the conjunction symbol is nothing but this one, product, in which each variable or its negation. If you take P as a variable, its negation will be negation P. So the reverse statement of P, but not both appears. See, if you take, for example, if there are two propositions, P and Q. So this is a conjunction symbol. P and Q, P and negation Q, negation P and Q, negation P and negation Q, but not both. P and negation P shouldn't appear. The minterms consists of the conjunctions. So this symbol is called conjunction, in which each variable or its negation, but not both appears. So these are all the minterms. So how it is related to PDNF? So in the principal disjunctive normal forms, so what is disjunction? So disjunction symbol is nothing but this one, sum. Sum is nothing but disjunction, and the symbol here is related to this is cup or. So this is a sum, the sum of all minterms. So these are all the minterms. If you add up all these minterms, so we'll be getting the principal disjunctive normal form. The sum of all minterms is called a principal disjunctive normal form. Such a normal form is called the sum of the product of canonical form. For example, so this is a minterm as it is associated with the conjunction symbol. So this is also the product of elementary sum. See here, this is the sum. The sum is nothing but the disjunction. So this is called the principal disjunctive normal form. So these are the sum, and in between what is there? Sum or disjunction. So in between whatever it is, so we'll call with that one. That is principal disjunctive normal form. So what is the working rule to solve this? So as usual, see here, the procedure to obtain the PDNF, the principal disjunctive normal form. First of all, in the problem, we have to remove all the implications and double implications using the equivalent formulas. And next one, again, we have to eliminate conjunction, disjunction using double negation, De Morgan's laws. So as we have so many equivalent formulas, so we have to apply all these in order to remove these. And next one, apply distributive law until a sum of elementary product are obtained. So we are going to use this distributive law, and after obtaining the disjunctive normal form, so now we have to introduce the missing factors. I'll show you how these missing factors are being added. And next, again, we have to apply equivalent formulas in order to get the principal disjunctive normal forms. See, it is very easy, as it is the thing, implication and double implication should be eliminated, and conjunction, disjunction are should be eliminated, and we have to use distributive laws until we get the sum of elementary products. So the sum of minterms. So we'll be getting the disjunctive normal forms. Again, we have to introduce the missing factors. So this is the additional thing which we have to do. Missing factors we have to add, and again we have to use equivalence formula in order to get principal disjunctive normal forms. I'll show you how it's going to happen. See, first one, according to our working rule, first of all, we have to obtain the principal disjunctive normal forms. So here, what is seen here? Implication is seen. So in order to use this implication, so we have a formula ready as an equivalence formula, that is P implies Q is nothing but negation P or Q. I'm going to apply this one. So in the solution, in order to get the PDNF, the first one, I'm going to remove this one, eliminate this implication, and I'm going to use this disjunction, negation P or Q. So this is negation P or Q. And we got DNF, disjunctive normal form. And we have to introduce this one. So in order to introduce the other one, see here, this is negation P. So for P, what is missing? Q is missing here. So in order to add up this one, I'm using the identity law. So true, or so for Q, what is missing? P is missing. So in order to introduce P, I'm using the identity law as Q and P is again Q according to our identity law. And in place of true, what I'm going to write, see here, negation P and in place of true, I'm going to write according to our negation formula. Here P is there, what we have to introduce? Q, that is Q or negation Q. See, clear? Or this is Q and in place of T, I'm going to write, see here, Q is there, what is missing? P is missing, P or negation P. So this is nothing but the negation law. According to our negation law, I'm using this one, P or negation P. So this is P here. And in order to use, so I'm going to use this distributive law. So here negation P is distributed to both and Q is distributed to both. So I'm going to use distribution law according to the distribution law. So this is identity law. So I have used the identity law. And this one, I have introduced this one using the negation law. So all the laws are very clear. And next one, I am going to distribute this negation P and Q. See here, negation P and Q, or negation P. See this one, negation P and negation Q. Clear? Or, and again, if I give Q to this one, that is Q and P, or, and this Q to negation P, that is Q and negation P. Clear? And see, if you see, all these are the minterms. So if you observe carefully, this is a minterm, therefore product of sum of minterms, that is negation P or Q, or negation P and negation Q, or that is Q and P, or this one is again Q and negation P. So what we have to call this one? So this is sum of minterms. Sum of minterms is nothing but principal disjunctive normal form. So this is how we have to use. The first one is P implication Q. We have to eliminate this implication, and after using this equivalent formula, and next one we have to introduce, as there is P, we have to introduce Q. So that I am using the identity law, that is unT, and this is unT. So in place of T, I am going to use P or negation Q or negation Q, and this is P or negation P. So again, I'm using the distributive law, and after distributing, these are all the minterms. So this is a disjunction or sum. The sum of all minterms is nothing but the principal disjunctive normal form. And the next important question here is, the second question here is also so easy. See here, there are no implications and double implications. Straight away we have to introduce, as there is Q here, we have to introduce P. So I'm using identity law, as Q and T is again Q according to our identity law. Here also for P there is no Q, so I'm introducing this true. P and true is again true. Or for negation Q, there is Q here, there is no P, so I'm introducing P here. So according to our negation law, so which law I'm going to use here? According to identity law here, according to identity law, I have written this one, and this one is according to our negation law. I am introducing the missing term here. So what is missing? For Q, P is missing, therefore P or negation P. Clear? And next one, P, and in place of true, I am going to write, as there is P, I am going to introduce Q or negation Q, or this is negation Q, or, so as there is Q here, I have to introduce P, negation P. Clear? And now which one I have to use? I have to use this distributive law. So Q should be distributed to these two, P should be distributed to these two, and this negation Q. So I am going to use this distribution law. So according to the distribution law, so we'll be getting the sum of the minterms. See, watch carefully. That is Q and P, or this is Q and negation P, or this is P and Q. This one is, or this is P and negation Q, or this is negation Q and P, or this is negation Q and negation P. Clear? So here if you observe these things, here there is P and Q, and here there is P and Q, and the next thing here is and P and negation Q. There is P and negation Q here, and there is P and negation Q here. These two are same. So we have to use an idempotent row, and you can use for one time. That is P and Q, P and Q. We can write it for one time. That is P and Q for one time, or this is Q and negation P. And instead of writing these for twice, I am using idempotent law and I am writing for one time. That is P and negation Q, or this is negation P and negation Q. This is negation Q and negation P. So here also if you observe sum of, so this is a sum of minterms, which is nothing but principal disjunctive normal form. Is it not easy? Is it not easy? First of all, we have to eliminate this one. We have to, as there is no implication or double implication, straight away we can add up the missing term. Here Q is there. For instead of writing P, I have introduced a true here. So instead of, for P, Q is missing. So for Q, I have written P T here, and for Q, I have introduced true instead of writing P. So after using the distributive law, and sum of all the minterms is nothing but PDNF. And the next important question here is obtain the PDNF of P or negation Q. See here, as there is no implication or double implication, straight away we can add up the missing term. Here there is P, and therefore I am introducing true. So according to our identity law, P and true is again true. And here for negation Q, what I have to introduce? P. So I am introducing true first of all. And the next one here, P, and in place of T I am writing Q is missing now. Q or negation Q. Clear? Or this is negation Q, or so there is Q here. What is missing? P is missing. Therefore P or negation P. Clear? And now which formula I have to use? So this is a negation formula. This is a negation law. According to the negation law, in place of T I have written this one. So this is identity law. Please remember, this is according to the identity equivalence laws. Now I am going to use distributive law. So which, according to our distributive law, so I am going to distribute each and every term here. So P is distributed to Q. That is P and Q, or this is P and negation Q, or here if I distribute this one, negation Q and P, and or this one is negation Q and negation P. Clear? And are there any terms, repeated terms? Yes, there is P and negation Q here, and there is P and negation Q here. So I am going to use the idempotent law. Instead of writing for two times, I am going to write one time, that is P and Q, or this is P and negation Q, or this is negation P and negation Q. So if you observe, this one is sum or disjunction. Here, as you know that sum of minterms is nothing but PDNF. So this is PDNF is nothing but principal disjunctive normal forms. As it is very easy if you follow. The thing here is there are implications here. First of all, we have to remove the implications. So in order to remove the implications, which equivalent formula we have to use? As you know that P implies Q is nothing but negation P or Q. So this is the equivalent formula which I am going to use. As I consider this as P and this whole thing as Q, then this would be negation P, or the whole thing you have to write. That one is P implies Q, and this is negation of negation Q, or this is negation P. So there is another implication here. So first thing is I have removed this one, and next one is I am going to remove this one using the same equivalence formula. And the next thing here is negation P or. So this can be written as negation P or Q, and this is if I send negation inside according to the De Morgan's law. I am going to use De Morgan's law. So if I introduce this De Morgan's law, if I send negation inside, this will be negation of negation Q, and or will become under negation of negation P. Clear? And next thing here is negation P or. This is negation P or Q. Same I am copying. So this is double negation law. According to our double negation law, so minus into minus positive. So this will be negation, negation, negation into negation. So this will be P and Q. Clear? And the next thing here is I'm going to use this distribution law. So clear? I'm going to use this distribution law for these two. According to the distribution law, this will be negation P or. So this whole thing, that is negation P. If you see, negation P, this symbol, and Q and this symbol. See, negation P and this one is Q and P. Clear? And next one, the symbol here is or, Q and, again this one is Q and P. Clear? So negation P is distributed to this bracket and Q is distributed to this bracket, and in between there is or here. And next one is I am going to use associative law. If I use associative law, what happens here? Associative law. As I can interchange these brackets, A into B into C can be written as A into B into C. So this value will be negation P or, if you observe properly. So here I am going to write these two in one bracket, and this is Q. Clear? Or, so this 2 for 2 times I am using idempotent law. Q and Q can be written as for one time, that is Q and P. Clear? So again this is of negation law. So as this is a negation law, according to the negation law, we can introduce this one, negation P or. So according to our negation law, this is false and Q, or this can be written as, according to the commutative law, this one is P and Q. And next one, according to identity law, if I use an identity law, what happens here? Next one is domination law here. So if I introduce domination law, so I have sent you all the laws here, so go through that one. Next one, this one is negation P or. So this is false and Q. So here there is and symbol here. False and Q is nothing but false, or this is P and Q. And next one is I am going to use identity law here. According to the identity law, keep all the laws ready. And this one will be negation P or. So this is false and P is again nothing but P and Q. So what is the missing term here? This is, if I introduce a T here, or, so this is P and Q are both there, P and Q. And see, in place of T I can write, what is missing? Q is missing, that is Q or, negation Q, or this is P and Q. So if I distribute these two, then this will be negation P and Q, or this is negation P and negation Q, or this is P and Q. If you observe, these are all the disjunctions. So these symbols are disjunctions. These are all the minterms. See here, the sum of minterms. So this is a sum symbol. Sum of minterms is nothing but PDNF. So PDNF is nothing but principal disjunctive normal form. This is how we have to calculate. First of all, we have to eliminate these implications, and after eliminating these implications, so again I have to introduce De Morgan's law, double negation law, and distributive law, associative law, negation, domination, identity law. So if you study all the 10 formula equivalent formulas, and if you can introduce this one. So after introducing the missing term here, for P, Q is missing. So after introducing this missing term and after using the distribution law, we got the sum of the minterms as PDNF. Clear? And the next important question here is, and the next one here is P and Q, or negation P or Q, or P and negation Q. As you can see, there are three propositions P, Q, R. See, I've covered each and every type of problem here related to negation, P, Q, R, and so on. See here, what is missing that you have to introduce. So here P and Q are there. So what is missing? R is missing. And so I'm writing T here according to our identity law. And next one, P and R are there. What is missing? Q is missing. So I'm writing T here. I am writing T here. So this is also the symbol. And or next one, P and R. So what is missing? P is missing. Instead of writing, I am writing T. I am using an identity law. See, this one can be written as P and Q, and what is missing? R is missing. Clearly you can write R as R or negation R, or this is negation P and R. P and R are there. What is missing? Q is missing. So Q or negation Q. Clear? Or here Q and R. So what is missing here? P is missing. That is P or negation P. Clear? Now which one I have to use? So I have to treat this one. I have to use this distribution law. So here P and Q is distributed to R as well as PR. So here also negation P is distributed to this bracket as well as this bracket. Q is distributed to this one as well as this one. And so I am going to use the distribution law, and therefore this can be written as P and Q. So this is whole bracket P and Q and R. Here OR symbol is there. Next P and Q and negation R. Clear? And here in between there is OR. This is negation P and, so this is whole bracket. So this one is whole bracket. Negation P and R and Q, or this is negation P and R, and this one is negation Q, or Q and R. So this is Q and R and P, or this is Q and R and negation P and negation P. Clear? So each one is distributed, and if you observe this one, PQR. So there is PQR here, there is PQR here, and the next one here is, there is again PQR. So this is PQR, and the thing here is, and what is repeated here? Negation PQR. Here there is negation PQR, negation PQR. So these two are repeated. So if I use the idempotent law, so it will be cut short as, so these two can be written for one time, that is P and Q and R, or this is P and Q and negation OR, and this can be written for one time, that is negation P and R and Q, and next one, this is left over, this is negation P and R and negation Q. So these are all the minterms. So these are all the minterms, and in between what is there? Disjunction or sum of minterms. See here, sum of minterms. Clear? Which is nothing but PDNF. So this is nothing but the PDNF. So this is the disjunction symbol. So in between what is there? Disjunction. So these are all the products. The product of all the minterms, or the sum of all the minterms is called PDNF. So this is how we have to solve. Hope you all guys understand. If you really understand, Thank you so much. And if you don't understand, go through this video for one more time and pass it on to your friends, siblings, friends, and whom you love the most. And please go through the playlist. So many videos are uploaded for your preparation. It will be very, very easy. And please do subscribe and follow this channel. Thank you so much.